recording to refer back to if you need it. So let's see, it's starting to think about recording. Anyway, so I'll let that start up. But yeah, so here I made this, I don't know, quite a while ago, I guess a year ago. And just kind of a program that demonstrates all the features that we learned about yesterday. So I'll just kind of review it here. Maybe I'll make it a bit bigger. Wrong window. So I have a string, and when you want to make a string variable, the name isn't very good, s, but it's small, so I can just, in this case, not use up a lot of screen space. It doesn't really have any particular meaning, so I'm just going to call it s. So this is the way to construct a string. We learned yesterday too that if you really want to, you can say new string L and put it in brackets, and that's running the constructor. But for string class only, Java allows you to omit doing that really long formal statement. You can just set it to a literal value, kind of like it's a primitive data type, even though it's not a primitive data type like an integer and a char. It's a class, right? That's why it has a capital S. Okay, so if we just say s.length, I'm just going to comment out the output here from the other question. So, I can just do a control / and comment those out. And I'm going to comment these guys as well, and this too. So then I can just run it. Okay, so if I say s.length and store it as len and then print it here, maybe in the chat you can say what you think it'll output. So we might have to do a bit of counting here. So just in the chat, what do you think it's going to output? Yep, 9, you counted correctly. Yeah, perfect. Yeah, so we can run that and just check, make sure. But yeah, there's no trick to length. It's just going to count up the number of characters. And yeah, the length of Thornhill is 9. Perfect. Okay, now let's try the next one. So we're doing a charAt, which stands for character at, and when you hover over it, it tells you an explanation of the method. It says that the indexes start from 0 to length -1, which we read earlier on the API. This is just pulling it right out of the API documentation. So yeah, what's charAt2 of Thornhill? So what is that going to output? An O. That is correct, because it's going to just run that. 0, 1, 2 is the O, right? So the only trick to that one is that index 2, starting from 0, gives you the O. So just have to remember it starts from 0. Okay, so next one, substring 1 to 5. That's going to be stored in part. So what is substring 1 to 5? What is that going to output? Yeah, I agree. I think it's horn. Let's check. Yes. Right. So the trick with this one is that it's inclusive of index 1, which is the H, but not inclusive of 5, which is the other H. So, so it's really just going to get these 4 value. So that's the somewhat tricky thing is to remember it's not inclusive of the second index that you specify. All right, what does substring 5 give us? Yeah, it gives us hill, which is, this is index 5, but if you just specify one index, it goes to the end of the string from that point. So that's what, if you specify one number, that's what substring is going to do. It's going to give the substring from that point to the end. So it should give us hill. Yeah. All right, and so we're gonna do toLowerCase and toUpperCase. Okay, that, and then if we print those out, that should be pretty straightforward. So let's run that one. Yeah, so it just changes it from proper case to all lowercase, and from proper case to all uppercase. So that's because we stored this in a new variable. Because this method, the toLowerCase method, it actually doesn't change what s is. So if we were to print s, and we did actually print s, it came out here, it was unchanged. So it's still Thornhill with a capital T, proper case, but it took that and converted it and stored it into a new variable. So all of these string methods return new strings and leave the original one alone. So yeah, that's kind of tricky. So that's what I explained here in this comment. When you use string methods, they never change the original string. Instead, they return a new string. So yeah, so s does not get changed. So if I do something like just this, and then I try and output it, I'll just do a control slash. You'll see that even though I've done it above, you'll see that it remains unchanged. So let me run that one. Okay, so it says, so after I do s.toUpperCase, the original string remains, and I print out, at the very end, I print out what s is, join on s, and it's still Thornhill with a capital T. So yeah, so that's tricky. Sometimes, you might be inclined to think that, oh, this is just going to convert s to uppercase and perfect, but it did that, and it returned a new string, but we didn't catch it into a variable as we did here. Now, the only other thing you could do is reuse the same variable to do this. That would sort of change it, but it actually doesn't. It actually destroys the old memory location and reference to that memory location in the RAM of your computer, and it makes s point to a brand new location with the uppercase version. So you kind of lose the old one and it gets recreated somewhere else in the RAM. So if I do this and print s, it would actually change it. So now it's all uppercase Thornhill, but it's actually done some behind the scenes things like making a new spot in memory for the new thing. So yeah, I mean, you can do that. There is a better way. We'll learn in grade 12, but yeah. And the last thing I just thought I would demonstrate is mentioned yesterday how you can typecast integers into chars. And so in this loop, it's going to start at character 33. I don't know if you remember, but character 32 is actually a space, so there's no point in printing that. It won't show up. And everything before that is kind of unprintable things anyways. So starting at 33 and going to the 7-bit ASCII codes, like I guess not including 27, I guess there are some other not so interesting characters up there. So I'm just going to make a for loop through all those numbers and print the number and then a hyphen, and I'm going to cast that number like 33 into a a char. So if I don't do this and I just print I, it's just going to print the number. But if I typecast I to a char, it's going to print the actual number, the actual character itself. So you can kind of see here that 33 is an exclamation mark, double quote, hashtag, $, etc. Right? A bunch of weird symbols. Then at 48, it starts with number digits, right? Up to 9, and then some more weird stuff. And then A is 65 because really that's 0, 1, a bunch of zeros and a 1 on the end. So it's kind of like the first character if you ignore the first few bits to the left side of it. Yeah, and then it just counts up by 1 each time until it gets to Z. Then it puts a bunch of other weird junk in there before it gets to A, which is like I think it would be 0, 1, 1, and then a 1 at the very right side of the group of 8 bits. And then, yeah, it goes 2, 3, 4. So it does kind of have some logic to that. Yeah, anyway, so that's just to show you that you can convert back and forth. And if I want to go the opposite way and I had chars, I can't really generate chars in a loop. But if I did have a char, I could take the int of it and find out what the numeric code for it is. Okay, so any questions with that? Okay, so yeah, so just to continue, this was part of the PowerPoint that I posted from yesterday, and it's just what we kind of ran through manually, so I won't go over that. Okay, so some new methods, more methods to remember or to reference to know what they do, kind of thing. Trim's kind of handy. It basically just removes all the white space. So by white space, what I mean is spaces, tabs, any sort of character that is non-printable, like enter key, that kind of thing. But it doesn't remove them from the middle of the string. So if you have a sentence with the spaces separating words, it doesn't trim in between. It just trims before and after. This is kind of handy if you have like input from a text box. If you're ever filling out a form on the web and you maybe autofill it and has a space at the end of your name or something has an extra space before or after, this will just trim those off, and handy to do so that if you're doing a comparison, it might have a better chance of matching, right? Because you don't need the spaces before and after. So replace, sometimes there are issues with this command that I've found, but in general it should work. I can maybe point out later what some of the cases that I have found that it doesn't work perfectly in, but yeah, you can replace a part of a string with something new, right? So it's just going to replace all the occurrences of whatever the string part is within the original. And then indexOf is just gonna, this one is actually very handy. So it's finding where in a string this, like what index this string is at. So probably, I'll give you some examples that'll make this a bit more clear. Also, if you want to search for a string and find out where it is in a word, in a larger string, you could say start searching from this location, right? So rather, this one just starts searching for the thing, this str from the beginning. This one says, okay, start searching for str, but only start at the 10th character or something, index 10, right? Last indexOf does the same thing, but the search happens from the back of the string and goes towards the beginning. These are all kind of handy for manipulating things. So here's a bit of an example. So again, I could run this program, but it's up here now. So you can see text has a space before and a bunch of spaces after. So you can trim those off, but it won't trim out the middle. So here, when I run it, it says, here's the original, is just text with the space before and the space after. So that comes out here. And then if I say after the trim, I do text.trim. And since I'm printing it in place, like before with toUpperCase, toLowerCase, it doesn't actually modify what text is. So it doesn't actually take those spaces off of the original string called text. But it will do that and print it. So the original one's still unchanged, but what it prints is the trimmed version, because this method returns a new string, a brand new string, and it gets sort of replaced here. So in the output, so you can see after it says, you know, I'm just putting these hashtags as delimiters. So it's going to say, it gets rid of that space there, and it gets rid of all the space at the end. And you can see how the delimiters are like butted up against the end of it now. So it's removed them all. But if we were to print out text again, it would just be still the original. It hasn't changed it. And \n is going to go to a new line just to create a bit of extra space there. And then here, yeah, I'm just doing a tab, so we can see that, you know, when we print this, it prints with a tab at the back of it. And when we do the trim of the second piece of text, it's actually trimmed that off so it's gone as well. So just proving that it trims off spaces before and after, but not between, and it will trim off weird characters like \t, like escape sequences that generate white space. Yeah, but only before and after. Yeah, so here's if I want to check out the replace method. So in text, this also kind of proves that text did not change. When you print it, you'll see it still has the white space before and after. But we're going to replace, so we're operating on text. So this is the object, our variable called text. We're calling its replace method. So within this here, it's going to replace hey with hello. So this is the thing that we want to replace, and this is what we're replacing it with. So now instead of saying hey there, it should say hello there. So it says hello there, and the other, yeah, and then it just, I guess that's from the other string. So yeah, so and then you can replace a space with no spaces. So it actually comes up, any space that was inside of it anywhere gets replaced with empty quotes, right? So yeah, so that's yeah, kind of interesting to try those out and see those. Yeah, so I mean, I think this one I changed a little bit after that, but I added some more things to this one to demonstrate indexOf. So yeah, we can, that's, yeah. So this is the part from the PowerPoint here. I did chop this other part out. So yeah, we can take a look at this one. Okay, so just erasing the answers there here. Okay, so we can play around with this one. So find the location of a string or a letter within the other string. That's the job of indexOf. So here we have word is Thornhill again. Just made a variable for the location of where we're finding things. Made a variable called first h, which is the location of the first h, because we're just doing an index of within word to find where h is. Okay, so h, you can predict that on your own, and we'll see what it prints here, because we're going to print this out here. So and then I'm going to just get rid of all this. Control slash that. Okay, so what do you think? What's it going to print out when, what integer is it going to be for first H? Sorry, go back to that. Just trying to get my chat here so I can see what people are responding with. So what's first H going to print? Or what's its value when it prints out first H? I know you got to do a lot of counting. Any guesses? The index of the first H. Did I lose you guys? Okay, so we have one guess, which is 1. So the first H is in position 1. Right, okay, so I would agree with that, because this is 0, that's 1, right? There are more H's, but it's just going to stop when it finds the first one. So yeah, that's good. Let's check it out. Yep, so it says 1. Perfect. Okay, so let's try now finding the index of hill. So index of hill, so it is going to match. So what do you think on this one? What's it going to return? It can only return one number, right? So it's got to find location of hill. 5, I think so. 0, 1, 2, 3, 4, 5. Yeah, I would agree. Let's try. Did not print that. Not again. Yep, 5. Good, good. Okay, so then, yeah, let's see what we can / those. Okay, so now we're looking for Bill in Thornhill. So now what do you think it might do here? I don't know if anybody knows, but it's obviously not in Thornhill. Bill is not in Thornhill. So, but what do you think this function is going to return? This method is going to return. It has to return an integer. So it can't really say like a message like not there. Yeah, good, Leo. Yeah, so you might have already known that or had some previous experience, but what it does is it returns a -1 as an indicator that it's not there, and that makes sense because the lowest number it could be is a 0, and that wouldn't be a good thing to return if you don't find it as 0, because that would mean it's in the first spot, and you couldn't really have it return like 99 or something like that, because it's possible that there is you know, that the string is long, right? And it could be 99. So -1 is, yeah, a good choice. So just confirm that's what it does. Yeah, -1. Index of Bill and Thornhill returns a -1. Good. Okay, so now we try and find the second H. Okay, so this is getting a little bit trickier. We're going to use index of here. And we're going to try and find the second H. So if you remember, like if we do index of H, we're just going to keep finding the same one. But since we already found the first H in position 0, 1, right? So when we ran this, found that the index of H, we stored it as position 1. Then what we can do to find the next H is we could use that overloaded method. So overloading of methods means you have two methods with the exact same name, like index of, index of. This index of only takes one string. This one takes one string followed by an integer. So this integer means where to start looking. So it's basically saying where you found the first one plus 1. So you don't want to start at where you found the first one, or you'll keep finding the exact same one. So let's start one after there. So it'll start searching from the O, which is where we found the first H, plus 1 is this location, and it'll start searching for the H. Doesn't find it, doesn't find it, doesn't find it. Oh, there it is there, right? So it'll find this one, and it'll report you the position, based on this being 0, right? So let me just run this one so you don't have to count. So it finds it in position 5, which is true, right? That's what we got before for hill, right? So it finds where the H is. And yeah, so this one's handy if you want to find multiple occurrences of something. And you can actually loop that. Now we know looping. We could keep looping, find where it is. From this, we could add 1 to it and search for more H's until, so if we were putting this in a loop to find all H's, what would the loop condition be? We'd say while index of, we're dot index of blah, blah, blah. So yeah, not equal to -1, right? Because -1 means it doesn't find it anymore. So if we keep searching, we find this H, and then we start searching again from here in a loop. We find another one, and then from here we start searching from this, and we go forward, but we don't find one, so it returns a -1. So our loop would just be, keep going while the index of returns something like greater than or equal to 0, or not equal to -1. Yeah, the alternative way to do it is just to do the last index of. If you just want to find the last occurrence of an H, there might be more, right? But I would just start searching from the end and go backwards until it finds, oh, there's the H, and it's in position 5. So it's still going to give us the same number, but it's just going to start searching from the other end. That's good for finding, like, maybe checking the file extension on something that's the very end of a word or a piece of text, right? So sometimes that's pretty handy. Or if you're looking for HTML tags and you want to search for the last ending tag, you could start searching using last index of. That makes sense in that case. Yeah. Any questions so far, or is that pretty straightforward? Okay. All right. So we kind of covered index of. We covered trimming. We covered, trimming, index of, last index of, the overloaded index ofs, and that's pretty much it. I don't want to start into the next part. I'll save that for tomorrow. Today, you can start some of the activities now. You can start